All right, so let me start the day with this talk about Dom0-less. So Dom0, as you know, has been the pillar of every Xen deployment since the very beginning, and this talk is about how to get rid of it. The name is, Artem came up with the name, so I want to give credit for the cool name for the project. Let's start giving a look at traditionally what happens. In this room, we should all be familiar with this, but, and also in the picture, I'm using ARM-specific terminology. It's also true that Dom0-less today is implemented only on ARM, but the concepts are applicable to x86, and I'm sure it could be implemented on x86 too. So we have the bootloader, so Uboot in this picture, boot Xen, Xen boot the Dom0 kernel, then you get the Dom0 user space to get up and running, you have init scripts, the Xen services become available, like Xen Store D, Xen Console D, and then finally you can use Excel, the command line tool, to start additional guests, such as the yellow VM and the purple VM here in this example. So this model has a few obvious consequences. One of them is the critical application that you want to run is going to be on the yellow or the purple VM. Why? Because we have been saying you shouldn't put your critical application in Dom0. If you do, that's a mistake. So Dom0 is only a service for the rest of the system to set up, to start, stop VM. It's not a good idea to put your apps in Dom0. So if that is the case and your app is in the yellow VM, but it should be, then to start the yellow VM, you need to wait at the very least for Xen to be up and running, for the Dom0 kernel to boot, for the Dom0 user space to come up, and all of it. So what I'm trying to say is that it's not fast. So with Xilinx as a little distro based on Yocto, pretty minimal distro. There is basically BusyBox, the Xen libraries, the Xen utilities, and nothing else. So it's very hard to go lower than that. And still, I think it will take 10 seconds overall to get through Xen, the kernel, and user space before you can start an additional VM. Now, for 10 seconds might be okay for most people, but there are some environments where it's a no-go, right? Specifically, one environment that we are trying to target is industrial, IoT and industrial in general, where often you have an industrial arm, a robotic arm of some sort in your factory, and until it's fully initialized, it can actually swing around and hitting people in the head, basically. That's not what you want to do. That's not what you want to happen for full 10 seconds, right? So typically, the initialization of these kind of functionalities need to happen within the fraction of a second. Typically, in the hundreds of milliseconds, which is a pretty harsh requirement in terms of boot times. So how do we solve this problem? We solve this problem by cutting the boot sequence and eliminating Dom0, and we'll see in a few slides. So let me go through this. So the boot time is obviously Xen plus the kernel and the user space in Dom0. There are other consequences so if you care about safety certification, because your environment requires a safety certification, because Dom0 is privileged over your system, you need to certify Dom0 too. So in this picture, so if this is your safety critical app, yellow needs to be safety certified. That's a given. Xen needs to be safety certified too, the hypervisor, but it's small. On ARM is less than 50,000 lines of code. But what about Dom0? So Dom0 is typically Linux-based, so that means it's challenging to certify, maybe impossible today. So you have a few options. One option would be to use a non-Linux Dom0. You can certainly do that. You can take one of the safety-certified RTOSes, such as Neutrino or QNX and others. And you have to write your own toolstack, though, because our toolstack wouldn't work on one of those operating systems out of the box. But then you might have an environment that's safety certifiable. Otherwise, another idea is you could quit Dom0 after boot. Now, this is not something we typically do, but it should be possible. And the reason why this is useful is the impact on safety certification of the boot system and compared to the runtime system is very different. So, but typically, you only need to safety certify the running system. So the boot system, such as Dom0, wouldn't necessarily need to be safety certified. But that wouldn't solve, of course, your boot time problem. Complexity, obviously, if you have Dom0, you need to build and deploy Dom0. And I'm telling you, like, at least from what I see, people trying to use Yocto to set up this system, they stumble across the build system every single time. Like, how to build it, how to set up the meta layers, how to load this additional VM, because these guys are experts of their own, safety critical app or their own app. They don't necessarily know about how to build a Dom0 system, how to deploy it. So it's not trivial. On the other hand, you have a very nice environment that you can use to monitor and start and stop VMs at runtime, which you can use. All right, so this is everything I said so far. You should know it very well. Now let's enter the new world of Dom0-less. How do we do it? So already Uboot is used. Well, your bootloader could be Grub, but today is Uboot. Is used to load a few binaries into memory. Is loading today the Xen hypervisor into memory, is loading the Dom0 kernel and ramdisk into memory, is also loading the device tree binary into memory. So we extend this protocol to also have Uboot load the kernel and ramdisk of any other DOM-U you want to load and boot at boot time. After that, we have Uboot start the Xen hypervisor, and the Xen hypervisor, instead of just starting Dom0, it will start all the VMs loaded in parallel. In parallel, of course, if you have enough CPU resources. So a typical configuration for us is to use a null scheduler, they fully dedicate a physical core to a virtual CPU in a one-to-one fashion to minimize IRQ latency and overhead in general of the scheduler. And then boot all the VMs on separate physical cores. So there are up to 4 cores on the board. We can start up to 4 1 vCPU VMs. What's the consequence of this? So the critical application is in a yellow VM. Yellow now needs to only wait for Xen to be fully booted before starting. So these VMs are typically tiny. So they are typically bare metal VMs. You might be more familiar with unikernels, but basically they are unikernel applications. So they will be up and running in just a bunch of milliseconds. That means having a boot time of less than a second is actually possible, because Xen doesn't take that long to boot. Even a default Xen not optimized without chopping out part of the boot code you don't need is going to boot in less than a second. So it becomes achievable. So the fact that we are starting VMs in parallel to Dom0, and we are calling this feature Dom0-less, doesn't actually mean you don't have Dom0. So Dom0-less are these 2 VMs, yellow and purple, that have been booted directly from Xen at boot time. And we call them Dom0-less VMs because Dom0 had no interaction whatsoever, no action, nothing to boot these VMs. It was completely idle. I mean, idle. It was booting. But it wasn't doing anything at all to get yellow and purple up and running. But you still have Dom0 there. So once Dom0 boots, you can still use Excel to start, stop PM, see what's up and running, and do anything that you usually do in Dom0. How does this all work under the hood? So first, you need to load all the binary in memory. So if you're not familiar with Uboot, it will be a pretty classic boot script that you will use to load the binary into memory and then start. So the first 4 lines are about TFTPing binaries into memory at given location. This is the device tree binary. This is the Dom0 kernel. This is the Xen hypervisor binary. That's the Dom0 ramdisk. The last one is the command to start the system. So this is what everybody is using today. What we are adding is a couple of lines for each additional VM to load a kernel and a RAM disk. Obviously, RAM disk is optional, so many of these tiny VMs don't even have a RAM disk, they just run in kernel space only. But the point is, you can load as many more as you need. You don't need any changes to Uboot to do that. But this is where what really gets interesting. So somehow you need to tell Xen that there are 2 more VMs to start. So you loaded the binaries into memory. Now Uboot needs to tell Xen where these binaries are, what to do with them. And this is done on via device tree. So device tree is should be only a hardware description language. But it also has a node called chosen, under which software configuration are provided. Specifically, chosen is used, for instance, to provide the Dom0 command line argument, well, the Linux command line argument in general, even when there is no Xen. When there is Xen, under the chosen node, you place the Xen command line argument, you place where Dom0 is in memory, you place where the Dom0 RAM disk is in memory. So we have expanded this protocol by introducing this concept of Xen domain. So here, this is a node that fully describes one VM. So it's compatible Xen domain. It has a certain amount of memory specified in kilobytes here. Yes, this example is wrong. I see Julian's face. It should be 2 numbers here. Anyway, so it's in kilobytes. This is the number of virtual CPUs. And this is about whether you want an emulated PL011, which is a very common ARM serial UART, to be provided to the guest. And the rest is information about your kernel and RAM disk. So where is it? Where the kernel is, where the RAM disk is, and the boot argument for the kernel. So providing this information for each VM to, so in this case, there would be 2, like one is yellow, one is purple, to then tell Xen everything the hypervisor needs to know in order to put them and start them. Okay, so everything I said so far maybe sounds cool. I hope it sounds cool, but actually it's kind of useless because PV drivers don't work. This is an issue today. You cannot really connect to the backends because the backends are not even up and running yet. Right? Dom0 is not there. I just said Dom0 play no role in the boot. That means there is no Xen store available to you. There is no PV drivers. All the usual interfaces are not there. So what are you going to do with your little Linux with a UART? Nothing, right? So in order to make it useful, you have device assignment. And that works today. So what you can do is you can take a device and fully assign it to these VMs. So for instance, you can take the network card and assign it to the yellow VM. The network card is a common example. It's not actually a very realistic example. So a more realistic example would be you take the CAN bus and you assign it to the yellow VM. So now you have your safety critical application that controls something over the CAN bus up and running in less than a second. Now this is interesting. But you can do it with all sorts of devices. So on the Xilinx board, there are also a pretty big FPGA space. So you can assign PL logic blocks to VMs, accelerator, all sorts of stuff. And leave the rest in Dom0 as usual. How do you do that? Well, we do it with device tree again. By loading into memory one more binary. The binary is a little device tree snippet that contains information about pass-through. So this is just the Domu node from before that we placed under the chosen node. This is the same as this, okay? And I just added one more module here. And the one more module is compatible multiple device tree, which means really this is for pass-through information. What's the content of that basically nested device tree binary? The content is the information about the device you are assigning to the guest. Note that today we already use this little device tree snippet to do device assignment on ARM. So this is no different than doing regular device assignment with Excel on an ARM platform. So what's the difference? There is actually only two differences that are the Xen path and the Xen regs attributes. They are to describe, to point to the, Xen path is to point to the path on the host device tree of the device you want to assign. And Xen reg is the memory map information. So the memory region of your device, at what location in the guest pseudo-physical address space do you want to have it mapped? One-to-one, different location. That's what the attribute is. There are other important things you should pay attention to, such as interrupt and interrupt parents, but those are also available already and present in the regular device tree we use today with Excel. They're no different. Okay, so once you do that, you can finally assign your device, such as a network card, to a VM and operate it almost instantaneously as soon as basically your VM starts. And this also enables you to do true Dom0-less configuration. So by true Dom0-less, I mean actually Dom0 is not there at all. Not that today this is not implemented, but it will be trivial to implement because already Dom0 plays no part in the boot sequence of yellow and purple. It's just that there is no way to ask Xen, please don't start Dom0. There is just no way to do that. Xen will insist on starting Dom0. And if it's not there, it's going to stop and complain. So why this configuration is useful? Because in embedded, this is actually the most common use case of them all. Because the classic use case in embedded is you have two things you want to really run. One is a supercritical, real-time sensitive application that you could be running in yellow, for instance. And the other one typically is a Linux-based, non-critical application, or maybe more than one application that are to do UI or information gathering and then sending them to the cloud, this kind of important but not actually critical operations. And you need to keep the two separate, so you typically actually two VMs are pretty good start and probably will satisfy like 80% of the use cases. Okay, so this is just a more advanced slide with some future-looking ideas, okay? So as I said, the fact that you have Dom0-less VM, it doesn't mean that you don't have Dom0, okay? So you can, and Dom0-less VMs are a very good fit for safety-critical apps because typically these apps need to be up and running very quickly, they have real-time requirements, et cetera, et cetera. So they are a good fit for running your RTOS, both yellow and purple. But you still have Dom0, so you can start additional VMs. So after Dom0 is booted, you can use Excel to boot another VM, as usual. Okay? You could use even CPU pools and dedicate the pool of the Dom0-less VM so that they have completely different scheduling parameters compared to this other dynamically started VM, which could use a credit scheduler as usual. And you could do overcommit, all sorts of things that you do normally on a server. You could also envision maybe to stop Dom0 using XSM policies from being able to touch the Dom0-less VMs. Now, this is not done today, but this is definitely conceivable because the Dom0-less VM are so limited in terms of an environment. They do no dynamic allocation, there is no ballooning, there is no PV driver, there is no event channel, there is nothing. So it's actually conceivable to prevent Dom0 from being able to do anything to them. And then it will become an interesting case. Okay, so yeah, this is just a slide to warn you again that PV drivers don't work with Dom0-less VM today, not even between two Dom0-less DOM-Us. And summary, so the main benefit is a much, much faster startup time. So if your requirement is to have a boot time of less than a second, Dom0-less is the way to go. Obviously, if you have safety certification requirements, Dom0-less chops off Dom0, so you have one less piece to safety certify. That's good, right? Complexity. So as I told you, like many people at the beginning especially stumble across the problem of having to deploy and configure Dom0. With Dom0-less, you don't have to configure Dom0 at all because there isn't necessarily a Dom0. Even if there is a Dom0, you don't need Xen tools in Dom0. So in order to build a Xen system with Dom0-less, you just need the cross-compiler, and that's it. So you cross-compile the hypervisor like you do Linux. You're done. You edit your device tree, and you have multiple VM up and running. So this is a great way to get people to start, and I've seen already people getting on board using Xen this way in a much easier way than before. So Yocto, for instance, if you didn't know about Yocto before, you don't need to know about Yocto now, as an example. Yes, your VM don't need config Xen. So if you're not going to use any of the PV drivers in your Dom0-less Dom-U, you might as well not have any Xen enablement at all in them. So I usually disable config Xen in the kernel I test with in my Dom0-less VMs because they are not going to use any Xen features anyway, so you might as well take it away. Cons. So there are cons, of course. One of them, the main cons is you don't have Dom0. Yes, you might be surprised how useful is Dom0, for instance, to check the health of the system, to check what the state of the VM is, to stop the VM or start VM again. If you don't have Dom0 in a true Dom0-less system, of course, then you cannot do that, of course. Also, Dom0-less VM cannot be rebooted today from Dom0 properly. You can stop them, and then they're not going to start unless you have the configuration also inside Dom0. And PV frontend and backend don't work, but that is on the roadmap. So the roadmap. What does it work today? So basic Dom0-less booting is already upstream since the 4.12 release. Device assignment is in progress. The series is on the list. I need to make progress. TODO. True Dom0-less, meaning an option to stop Dom0 from starting. That's on the to-do list. Another thing on the to-do list is to be able to share memory between VMs. Like one thing is PV drivers, but basic share memory, like one shared page between VMs, that should be easy and very useful. Then you can set up communication framework on top of them, like OpenUp. And that is on the to-do list. PV frontend and backend driver, that would be great to have, but it's going to be a bit farther out because that is a bit more difficult to implement. All right, so what I'm going to show you is now a demo of a system that boots Xen and 3 VMs in parallel. So that would be Xen, the yellow and purple VM here, so Dom-U1 and Dom-U2. I have taken the network card out of Dom0 and assigned it to one of the Dom0-less VMs. So yellow VM is the only one with network access. And then I use Excel in Dom0 to start one more VM. And with PV backends as usual, and communicate with Dom0. I could have used the Xen network frontend and the backend drivers, as I would have worked, but to make it more interesting and fun, I used PVCalls instead. So yes, this is a situation. So we have yellow VM is the only one that can talk to the internet because it's the only one with the network card. And then you have a private network between Dom0 and Dom-U, which is very private because none of them have a network card. So you're pretty sure that they cannot reach anything, not even close to the internet. Okay, so let's see how this goes. So you'll see now Uboot loading a bunch of binaries into memory and then starting Xen. And then you see a lot of mess on the console because you see 3 VMs starting at the same time. All of them starting now. And now that's done. The others are finished, and we just have to wait for Dom0 to finish booting, which, as I said, takes some time. Now Dom0 is up and running. I'm switching, so you can use Ctrl+A to switch between VM. And I used Ctrl-AAA to switch to the first VM, which will be the yellow VM in your example. If you do an fconfig, you see that it does have an IP address, and it can ping the outside world, which in this case is my workstation, but it can reach outside. Now, I use Ctrl-AAA a couple of times again to switch to the other VM again, Xen and Dom0. So basically, you circle across the VM using Ctrl-AAA in a circle fashion. Then I'm going to log into Dom0. If you do Excel list, you can still see the Dom0-less VMs, right? They are there. They don't have a name. Here they have a null name because, well, the name is on Xenstor, and they've been started without Xenstor. So unfortunately, today they show with no name. And they have the amount of memory we specified and the number of vCPUs that we specified. So the next thing I'm going to do is I'm going to just start one more VM just to show that you can start additional VMs. This is a configuration. It's just another VM with 128 megabytes of RAM, a kernel, a RAM disk. It has a PVCall front-end and back-end driver set. It started, and now what I'm going to do is just as an example, I'm going to start an HTTPD server inside the DOMU, and then fetch the page from Dom0 just to show that you can do communication, even so there is obviously nothing, not even close to the internet. So I wrote chow to index.html. I'm showing there is only loopback because this is PVCalls. When you use PVCalls, there is not even a fake network interface shown. And then I'm just starting HTTPD and fetching the page from Dom0. Dom0 also has only loopback. Why is that only loopback? Because Dom0 also has no network interfaces, not even fake. Fetching the page, and chow is there. Okay, that's the end of the demo. I have many more things to show, but unfortunately I'm out of time, so I'm going to take questions instead.
Any questions? No?
Stefano, you were saying that once you start those DOMUs, you have to pin.
Yeah.
Can you show the pin in Dom0? And
can
you not pin?
Yes, I can definitely not ping. So this is a recorded demo. I have another demo live that I can show you actually. I wanted to show you, but I'm out of time. But yes, it wouldn't ping at all. I mean, it would ping as far as loopback can let you ping.
And you have to extend your device tree to show that pinning.
You have to set your device tree?
How do you tell Xen how to pin if you create the DOMUs from device tree?
You do it with basically, because you specify, like I showed you in the slide. So ping works because the network card is there, right? The network card is there because I add the device tree snippet.
Are we talking about ping?
No, yeah. So you pin. So you're saying that in device tree you have a CPU equal to 1 or 2.
Right.
And then you say that those virtual CPUs are pinned. So
good question. So what I did, I use the null scheduler. The null scheduler automatically does 1 vCPU per physical CPU, so everything is automatically pinned. So this is the missing feature. What you just so it would be nice to be able to pin vCPU from the configuration and with the credit scheduler, for instance, and it should be possible and not difficult also, but it's not done. So you cannot do that today. You cannot use credit.
Okay, and another question is, I do believe you would have restarting all those DOMUs from Dom0 on your to-do list, because if DOMUs misbehave, you need to restart those bare metal applications.
Yes. So what will be possible to do today is you replicate your DOMU configuration in Dom0 with an Excel file. Of course, you can stop it and start it again.
Okay, thank you.
Yeah.
So I guess is anyone interested to see that additional demo? We could set something up where you guys can meet Stefano in one of the breaks. So who wants to see stuff? Raise your hands. So we have a few people. So what break would be just after this session?
Yeah.
Yeah, find Stefano somewhere, somewhere in the room. and I'm sure he can show you the demo. And thank you very much. Or are there any more questions? All right, thank you.